Dear colleagues, I'm Shanlong Lu from the International Research Center of Big Data for Sustainable Development Goals at Aerospace Information Research Institute, Chinese Academy of Sciences. My presentation topic is new remote sensing technology for hydrology of rivers, lakes, and reservoirs. The real-time acquisition of river discharge, lake, and reservoir water storage is fundamental for precise water resource management, flood, and drought disaster prevention. However, due to the sparse network of river hydrological observation stations and the scarcity of measured underwater terrain data in lakes and reservoirs, the global and regional hydrological dynamics remain largely unknown. This lack of data affects our ability to respond accurately and timely to water resource scarcity and water disasters amidst global climate change. Nevertheless, the accumulation of satellite remote sensing data over recent decades, alongside the diverse array of satellite resources currently in orbit, offers a valuable source for acquiring time series hydrological data for rivers, lakes, and reservoirs in regions lacking conventional data sources. In our study, we have proposed novel methods for calculating lake water storage and river discharge using remote sensing technology. The fundamental principle behind our approach is that the lake bed and river bed, along with their surrounding environment, are often shaped by similar geological processes, and the topography of the surrounding land surface can serve as a useful indicator for lake and river bathymetry. For lake water calculation method, we have developed an underwater topography simulation method. This method utilizes a digital elevation model as the primary input, employing slope information from 8 aspects of the lake above the water surface and generated equations for calculating the water depth pixel by pixel along the water boundary of the lake. Subsequently, we utilize the remote sensing surface water area data as input to calculate the water volume of the lake. An illustrative example is presented in this slide, featuring a lake on Tibet Plateau of China. Our method demonstrates precise simulation of underwater terrain. For further details on our methodology and its application, please refer to our published paper here. Utilizing a similar principle, we have proposed a new method for estimating river discharge. This method involves simulating the underwater terrain of a river section using digital elevation data of the river basin. We then calculate the key parameters such as cross-section area, wetted perimeter, and water surface slope. Subsequently, we determine velocity and discharging using a Gauquelin-Manning-Strickler formula with a time series of river surface water width serving as the sole input data. Our case study conducted on the Yellow River of China showcases the potential and the effectiveness of this method in river discharge estimation. We are currently preparing an article on this achievement, which we anticipate will be published this year. In summary, The remote sensing estimation method we have developed offers an effective solution to the problem of insufficient hydrological data in data scarce regions. Our case study demonstrates that the relative accuracy of a river discharge derived from remote sensing exceeds 80%. Additionally, we have developed a global dataset comprising 2,478 underwater terrain topographies and water storage estimates for lakes larger than 50 square kilometers, with relative errors for simulated water depths and estimated water storage at 29.5% and 9.3% respectively. This is my presentation. Thank you for your attention.